So today's question is preemptive priority algorithm. For that we have to find the average waiting time and average turnaround time. So in this case priorities are also given and arrival time is also given. So for that, as we are going for preemptive one, we are going to write the formula for calculating the average waiting time is start time minus the arrival time, and for the turnaround time the formula will be waiting time plus burst time. Okay, so it is the waiting time plus the burst time. So now we will draw the Gantt chart for finding the average waiting time and average turnaround time. Here the arrival time is mentioned as 1. So according at this time on your question only P0 is present. So only P0 is present in your question. So we cannot compare the priority with the remaining processes because this is the only one question, only one process in your question. So what are we going to do? We will start execution of P0. As this is preemptive one, only the one time slot will be given. So P0 will be executed only for one time slot. Now at that time, what is the waiting time for the first time of P0? So the P0 has started at 1 millisecond one time slot and it has arrived at one time slot. So it will be 1 minus 1. Now till when it is the second time slot. So in the question P1 is now arrived. So in the question we are having P0 and P1. Now we are going to compare the priorities of both the processes. So at the second time slot P1 has entered into the queue. So now what we are going to do, we are going to stop, we are going to preempt the P0. So here out of 3 time slot that is needed, 1 is already given, so remaining will be 2. Now to compare the priorities, so 3 means the lowest priority as compared to 2. So 2 is having the highest priority as compared to your process P0. So the chance will be given to P1. So P1 is now going to start. So P1 has started. So the start time for the P1 is 1, and what was the the start time for the P1 is 2. At what time it has arrived? It has arrived at 2. Okay, so as this is the preemptive one, we are going to run your processes only for the one time slot. Out of 2, P1 has executed for the one time slot, so the remaining time slot is 1. Now at third time slot, in your question P2 is also added. So now you compare the priorities. The P2 is having the lowest priority as compared to P2. Now P2 is having the highest as compared to P1. So what we are going to do, we are going to suspend the execution of P1. The P2 will be given the chance. So at what time P2 has started? P2 has started at third time slot and P2 is also arrived at third time slot. Okay, so this is the waiting time for the first term. So now as this is preemptive one, we are going to run only for one time slot. Out of 10, one time slot is given to P2. So the remaining is now 9. Now at 4th millisecond, at 4th time slot, your table is now completed. No more processes are going to be added. So what are you going to do? Now we compare the priority of P2 with the remaining one. So we can find that P2 is having the highest one as compared to remaining one, and luckily the P2 is already in the execution. So what we are not going to do, we are not going to stop P2. The P2 is going to continue. So if the P2 is going to continue, so what will the remaining time slot, that is the 9 millisecond, 9 millisecond will also be given to P2. So P2 is going to complete its execution. So 9 plus 4 will be now 13. So P2 is now completed. Now whose chance will be next? Now this question, after all the time slot is considered, is going to be converted into non-preemptive priority algorithm. Once the chance is given, the process is not going to be preempted. So the second highest priority process is P1. So P1 will be given the chance. For how many seconds the P1 is going to execute? Only for 1, because that was the remaining time slot. Now at what times P1 has started his execution for the second term? P1 has started the execution at 13. And what was the previous case where it has stopped? It has stopped at 3rd millisecond. Okay. Now the remaining will be the P0 is only the one process which is remaining. It will be given the chance only for 2 milliseconds because that was the remaining one. So 2 plus 14 will be 16. Now what will be the second chance P0 waiting time? At what time it has started? 14. At what time it has stopped previously? That is 2. So 14 minus 2 will be the waiting time. So the waiting time for your P0 will be 1 minus 1 will be 0. 4 minus 2 will be 12. I can write here, that is the waiting time for P0. Now 2 minus 2 for P1 is 0. 13 minus 3, that will be the waiting time for your process P1, and for the waiting time for P2 it will be 0. So what will be the average waiting time will be 12 plus 10 plus 0 divided by 3. That will be your waiting time, average waiting time. Now the turnaround time is waiting time plus burst time. Waiting time for P0 is 12 plus the burst time is 3, that will be 15. Waiting time for P1 is 10 with the burst time is 2, so it will be 12. Waiting time for P0 is 0 and the burst time is 10, so that will be 10. So the average turnaround time will be 15 plus 12 plus 10 divided by 3 will be your average waiting time.